Dinosaurs Rex was a 10,000-pound, self-propelled anti-tank weapon.
For the first time in 65 million years, cutting-edge imaging technology lets us look deep inside their bodies to reveal just how the world's greatest carnivores really work. Dinosaurs arm themselves with the most advanced weaponry nature has ever unleashed. Tools that allow them to survive for over 100 million years. North America, 115 million years ago. Reptilian creatures have evolved into killing machines like never seen before. Death is everywhere, sweeping down from the air, stalking the forest, and sometimes thundering through the trees in the form of Tyrannosaurus Rex.
T-Rex was the ultimate predator in the history of terrestrial animals.
T-Rex is one of the largest and deadliest animals ever to walk on two legs. For 2 million years, it rules the American West. Powerful and intelligent, this predator is equipped with the tools to bring down massive and well-armed prey.
The head, the skull of T-Rex is awesomely large.
And each tooth is an armor-crushing weapon.
Tyrannosaurus Rex means Tyrant Lizard King. This apex predator is 40 feet long, 18 feet high, and weighs in at 7 tons. The jaws of T-Rex are infamous. 5 feet of sheer terror, with 60 teeth, some as long as 12 inches. Its skull is constructed of 64 bones, a design that's light yet strong, 16 times stronger than the jaws of an alligator. The front teeth are dagger-shaped with serrated edges designed to tear flesh. The larger side teeth are rounded, perfect for crunching bone. Solidly anchored into muscle, they can withstand pressure from any direction.
We have a pretty good idea of how it killed its prey. It seems to have just walked right up to them, taken a bite, and whatever happens, happens.
Unlike many dinosaurs, they wouldn't just take the flesh off the carcass. They'd basically eat most of the carcass.
T-Rex huge legs and pelvis make up half this bruiser's total body weight. Its tail weighs a full ton. The reason? It has to balance out 1,000 pounds of head and jaws. The head is 2/3 muscle, able to power jaws capable of clamping down with enough force to bite through a steel oil drum. All that muscle delivers a bite strong enough to take down the toughest prey of the Cretaceous.
T-Rex teeth are among the bluntest teeth, least sharp, of the whole family of tyrannosaurs. Those teeth are designed to crush, to penetrate thick layers of armor and muscle in a crushing, massive, hemorrhaging blow.
The muscles in T-Rex's neck are nearly as powerful as the muscles in its legs. At 2 feet thick, they are strong enough to lift a hippo or bring down the most well-armed, best-defended herbivore nature has ever produced, Triceratops.
The best way to attack Triceratops is with a long-barreled 75mm anti-tank gun.
Triceratops protects itself with a bony shield called a frill and can fend off an attacker with a pair of 4-foot-long swords.
You've got to crush it. The only way to deal with this huge, curved, cantilevered, composite armor is a crushing blow with multiple teeth.
But defeating a Triceratops takes more than just teeth. It requires power. Triceratops' most dangerous weapons are mounted on a skull that can swivel 360 degrees.
Triceratops would want to keep that horns and the frill pointed right at T-Rex.
For a T-Rex, the key to defeating a Triceratops is those supersized jaws. Behind this killer's bite are two sets of powerful muscles. The first runs from the top of the skull down to the bottom of the jaw. These muscles give this carnivore's bite its speed. The second set, muscles which make up almost 50% of the muscles in the head, wrap around the lower jaw, tying it to the roof of the mouth. They give T-Rex's bite its 7,000 pounds of force, twice the chomping power of a great white shark. And there's more. Just like a python, T-Rex can dislocate its jaw.
Craniokinesis is basically the ability to swallow things larger than your own head. That's because the skull expands as it opens up. Snakes swallowing whole chicken eggs, a snake head that's much smaller than the egg, and it'll swallow that whole egg. There's not a lawyer in this world that's too fat that his T-Rex couldn't swallow him whole.
Tyrannosaurus rex is a carnivorous monster that uses sheer force to overpower well-defended prey. It's truly unlike any other creature that has walked the planet.
T-Rex is different. Something about Tyrannosaurs and Tyrannosaurus rex itself is different than other predatory dinosaurs.
But for such a celebrated killer, able to take on the toughest creatures of the Cretaceous, some things just don't add up. It's slow. Top speed, not much more than 15 miles per hour. A T-Rex couldn't even outrun a fit human. It's also unwieldy, requiring a full 2 seconds to make a 45-degree turn.
If a T-Rex were to fall over while chasing a prey item, it might seriously wound itself.
And its hands, with only 2 fingers, are completely useless for gripping prey.
After its giant size and its huge teeth, the thing we most notice about T-Rex are its dinky little arms, these tiny little arms that can't even reach its mouth.
The giant T-Rex is a baffling creature. There has to be more to this killer. How did this giant mouth on legs become the dreaded butcher of the Cretaceous? Was it raw power, its shark-like jaws, or something else entirely? Fossils of Tyrannosaurus rex have been unearthed in the US, Canada, even Asia. For scientists, these discoveries point to one conclusion. This carnivore has little to fear, even from the most well-armed herbivore of the Cretaceous, Triceratops. But to bring down an animal this tough takes more than just brawn, muscle, and teeth. It requires planning and strategy. In short, brains. And T-Rex delivers. Its cerebrum is one of the largest of the prehistoric world. It has the ability to process sophisticated sensory information. Hearing, smell, sight, all are highly refined.
We can look at the sense of vision and see the attributes of a predator.
T-Rex's eyes are 16 inches apart, giving this killer exceptional binocular vision. The ability to perceive depth.
Now, an eye is essentially just a photon-catching device. Tyrannosaurs would have had an extremely large retina over which they could collect those photons.
Collecting more photons gives the brain more visual information to interpret, more detail about its surroundings. And something else about those eyes is crucial for an apex hunter.
A Tyrannosaurus' eyes were quite high up, and therefore they always had a very tall perspective on the world and can see great distances. For them, the horizon was very, very far away.
T-Rex can distinguish fine visual detail as far away as 4 miles. That's about 6 times further than we can see. Its hearing as well is a significant advantage for a hunter.
What we see in the inner ear of T-Rex is a hearing organ that's long and suggests that hearing was very important to T-Rex.
Called the cochlea, it's a hollow cone-shaped tube filled with liquid. This tube vibrates in response to sound waves. Thousands of tiny hair-like cells detect this movement, then send electrical signals to the brain. The cochlea in a Tyrannosaurus rex is almost an inch long, meaning it can pick up a wide range of frequencies.
It was able to actually hear very low frequency sounds, and so something even off in the distance was going to be within its perceptive world.
It doesn't want to hear the peeping and piping of little birds around there because they're not going to be something it eats. But if it's hearing the infrasound grunts of a Triceratops, that's what it wants to hear, because that sound is going to mean that's where lunch is.
A battle with Triceratops is more often than not a death match. This herbivore hasn't evolved into a Sherman tank for nothing.
Now, as a Tyrannosaur specialist, I don't like to admit this, but in that situation, a Triceratops probably won, and it probably won on a regular basis.
It looks as if this battle will end in a draw. The barbarian of the Cretaceous walks away empty-handed. Because T-Rex are warm-blooded, they need to maintain their body temperature. This means consuming huge amounts of energy, over 1 million calories every week. That's 1,500 pounds of raw meat. Quite a few kills, even for a super predator. But maybe T-Rex scores a meal some other way. Maybe Tyrannosaurus Rex has the guts to steal a kill from a rival carnivore.
The reality is it's got all the tools of a predator, and those tools of a predator serve a scavenger equally well.
One of those tools is its nose, the most sensitive found on any carnivorous dinosaur.
I can tell you that that good sense of smell was awesome for finding carcasses, and when it did, it ate those carcasses.
A dead Triceratops. Another predator's kill? For Tyrannosaurus Rex, scavenging comes with substantial risk. Muscling in on someone else's dinner can end badly. Very badly. But a T-Rex can take on almost any other meat eater, even another T-Rex. And when it's Tyrannosaur versus Tyrannosaur, it's winner take all.
Cannibalism in nature doesn't seem to be a matter of pleasure. It's a matter of business.
T-Rex meat is T-Rex food as well. You know, it's protein. It's something that will help that individual survive to the next kill.
Attacking a T-Rex seems like suicide. But that may only be true if you're something other than another Tyrannosaurus Rex.
Cannibalism is the rule. It's not the exception. If you're a carnivore and there's meat there, you take advantage of it.
In fact, paleontologists have found ample evidence of cannibalism in the bones of these giants.
We find tooth marks on the bones of T-Rex and parts of the bones missing on the T-Rex, and clearly they were eaten by another T-Rex. There's nothing else that could have bitten those bones in half.
Tyrannosaurus Rex is powerful and intelligent, but it's slow, lumbering, and ponderous. A predator who at times must even scavenge to survive. The age of dinosaurs, though, is all about adaptation. And for one carnivorous killer, survival means trading size and muscle for speed, agility, and razor-sharp weaponry. It's a creature that proves that in this prehistoric world, death can come in any size. Deinonychus is a raptor, a bird-like predator covered in feathers. It's 5 feet high, 10 feet long, and weighs 200 pounds. Tiny by dinosaur standards. Deinonychus is a hunter with a toolkit unlike any animal in the world today. Teeth, claws, speed. It has it all.
Deinonychus, you have an animal that has very nasty, sharp teeth and lots of them. And if that weren't enough, it has enormous inner claws on its feet. It's as if it just couldn't get enough weaponry.
Deinonychus is more than just a well-armed carnivore. It's intelligent. This predator can stalk a meal, plan out an attack, then take down prey with deadly precision. Even one of the largest plant eaters of all time, Sauroposeidon. Its name means lizard earthquake god, and it can grow to a neck-craning 60 feet tall and 50 tons in weight. Sauroposeidon towers over Deinonychus. In fact, its mammoth size is its primary defense. But like all creatures, this giant starts out small.
For Deinonychus, Sauroposeidon would be a great meal, at least the juveniles, because there would have been lots of them and because they would have been effectively defenseless.
When Sauroposeidon reaches full size at around 25 years old, nothing can touch it. But this Goliath starts out about the size of a house cat. When these eggs hatch, the young grow fast, but not fast enough. They won't even reach a ton in weight for at least 3 years. That's 3 years with the raptor Deinonychus nipping at its heels.
There's good evidence that Deinonychus killed animals that weighed 10 times as much as it.
And 10 times Deinonychus's weight in raw meat is one big meal.
And they could probably feast for a while on, let's say, a 3-year-old Sauroposeidon, an animal the size of a hippo.
Bringing down an animal 10 times your size takes more than just brains. It requires highly advanced senses.
We can tell that it had a good sense of vision, good hearing, and a pretty good sense of smell.
In fact, like few carnivores of its day, Deinonychus has a sense of smell so acute it can track prey in the dead of night. Inside the snout are 2 nasal passages. Like a prehistoric air filter, sheets of sensory tissue are folded to maximize surface area. This tissue contains millions of chemoreceptors, nerves that capture odor molecules. The result, Deinonychus can sniff out prey from miles away.
Sense of smell in Deinonychus could alert it to a herd, a family group of plant eaters 10, 15, 20, 30 miles away.
And Sauroposeidon, like most plant eaters, are smelly. Unlike a meat eater, they produce huge amounts of waste, feces that form a trail marking everywhere they've been. For Deinonychus, that odor is a dead giveaway. And this carnivore's eyes can clearly see prey from a great distance. A scan of a Deinonychus skull reveals a brain with an oversized optic nerve, the nerve which transmits visual information from the eyes.
The optic nerve is very large too, and the eye socket is very large.
It's like having a broadband connection between the eyes and the brain. This high-speed link means Deinonychus can react quickly to even subtle changes in its environment.
If we look at the Deinonychus eye, it's probably going to be about 1 inch across. A lot of space in there for photoreceptors. Could see well at night. Would have just a superb sense of sight.
Unlike a mammal, Deinonychus has no blood vessels in its retina, what we see as red eye in flash photographs. This simple design change creates space for many more rods and cones. More than twice the number of photoreceptors found in the human retina. And all those additional rods means this carnivore can see in the dark. It's as if Deinonychus looks at the world through night vision goggles.
This animal had very sensitive vision, being able to actually discriminate objects with great clarity and acute vision.
These are the characteristics of an apex hunter, a land shark. Yet highly advanced senses are just the beginning. Deinonychus is agile and can reach speeds of 40 miles per hour. Plus, it has near-perfect balance.
It would have been swift. It would have been swifter than a human being, certainly. But its real ability would have been agility. It's a sort of animal that could probably turn on a dime.
These Olympic capabilities come down to one simple anatomical feature: its tail. Half the length of its body, it acts like a built-in counterbalance. By flicking it from side to side, it can make a sharp turn at full speed.
If we were to look at Deinonychus in slow motion chasing after a prey item, it would look a lot like a big cat today. If the prey item tries to dart away, it turns even faster than it, swinging its tail off to the side, and can cut it off and intercept that prey item as it's trying to get away.
Put all this together: speed, agility, a powerful sense of smell, and a young sauroposeidon, even an animal 2,000 pounds in weight, might just be staring death in the face, particularly if there's more than one Deinonychus on its tail.
Fight back.
The plant-eater sauroposeidon defends itself by growing to mammoth proportions. This one is a juvenile, but it's almost 20 feet tall, an animal on the edge of adolescence, and an animal on the run. On its tail are not just one, but two raptors. Raptors that go by the name Deinonychus. These pint-sized killers work as a team.
Deinonychus wouldn't weigh much more than a human being. And when they're attacking things like sauroposeidon, it would be a big advantage for them to be able to act as a group.
They're actually increasing their chance of getting a meal.
It's a strategy still used today. Working together, lions will take on prey as big as a 4-ton elephant, and they only have teeth and claws. Deinonychus employs an array of weaponry more powerful than any creature today. Sauroposeidon's only defense is its massive size, but Deinonychus have learned that nearly any defense can be breached with the right armaments. Like recurved hand claws, almost 3 inches long, designed to grip into the bodies of prey like a mountain climber's spikes.
The ideal attack is to jump up, grab a hold of the prey, position the prey, and then strike. So the arms are to position your body to deliver that killing blow.
It could strike very quickly, and it could, if it was attacking a larger animal, use those arms to pull itself up against it. By doing so, it could bring its other main weapon into attack, and that's its foot claw.
The name Deinonychus means terrible claw. It's a reference to the hinged bone on its foot. The cutting edge is sheathed in keratin, the same substance that forms a cat's claw. But on a Deinonychus, this claw is 4 inches long. Like a built-in switchblade, this lethal weapon is sharpened to a point and can flex almost 180 degrees. To keep the knife razor sharp, Deinonychus holds it up off the ground until the moment it's needed. Then, in one lightning-fast swipe, this sickle can rip deep into flesh. Delivered a kicking blow with 450 pounds of cutting force.
The key to the Deinonychus killing blow is the hind leg. Hind leg is the strongest organ in the body by far, and ends in a huge claw like a box-cutting knife. So that cutting curved knife into your belly, into the target, would cause a fatal wound with one flexion.
Deinonychus instinctively knows to go for this giant's weakness, its neck.
You've got the windpipe there, you've got the jugular vein, which, if opened up, will mean that that sauroposeidon is dead meat.
But death does not come quickly or pleasantly. For a pack of Deinonychus, a kill this big means a feast. And their skulls are specially designed for competitive eating. Its jaws are narrow and lightly built, and its gums are equipped with 70 sharp, serrated teeth. They're like walking piranhas, perfect at eviscerating a victim.
If you look at the teeth carefully, they're ridiculously small. They are very, very delicate. They're not killing weapons.
A single adolescent sauroposeidon, an animal more than 10 times the size of its killer, can feed a pack of hungry Deinonychus for weeks. This kill was worth the effort and the risk. Texas, 68 million years ago. Here, death comes not only from well-armed gargantuan dinosaurs. Sometimes it swoops down from the sky on the wings of a flying reptile, Quetzalcoatlus.
Quetzalcoatlus could be kind of seen as a Cretaceous stealth bomber. Air-to-ground weaponry at its finest.
They weren't big, fragile kites. They were big, mean, terrifying bats from hell.
Quetzalcoatlus is arguably the largest, most sophisticated animal ever to fly. A wingspan of almost 40 feet holds aloft a body weighing 400 pounds. That's the wingspan of the Wright brothers' first flyer.
Picture a living plane, and that gives you a sense of what Quetzalcoatlus would look like in life.
I mean, this is an animal that probably accelerates over 2.5 Gs just on takeoff.
Just beyond our comprehension.
A Quetzalcoatlus is 10 times the weight of the largest flying bird today. Yet this airborne reptile doesn't rely on feathers. Its wings are made of skin. Almost half of that wing is supported by an extended finger bone, a finger 8 feet long. A second bone lines the front of the wing, forming a leading edge similar to an aircraft. This aerodynamic design allows for near perfect control on takeoff and landing. But for this flying monster, getting off the ground is the hardest task.
Big pterosaur like Quetzalcoatlus, giraffe height, on all fours, and it's got to get up into the air. How's it going to do that?
Calling the plains of Texas home makes that job even more difficult.
Flat ground, no hills, no cliffs, no special conditions, nothing to help it at all except its muscles. It could still take off from a standstill without any running required.
The secret to how this Goliath takes off can be seen in a creature 1,000 times smaller, the vampire bat.
They have to spring up into the air. They have to do essentially a super push-up with their powerful forelimbs, the strongest limbs they have, get up high enough that they can get their wings to flap and get off the ground.
A Quetzalcoatlus takes off in the same way, using all 4 limbs to suddenly leap up into the air. Its powerful arm muscles are composed of 80% fast-twitch fiber, a third more than humans. This specialized muscle tissue is capable of delivering rapid bursts of energy. Energy needed to propel this reptile, a creature weighing as much as a grizzly bear, from a dead stop to a launch speed of 30 miles per hour, all in a fraction of a second.
I think that seeing a pterosaur like Quetzalcoatlus actually take off would have to be one of the most impressive sights in the animal kingdom. And to see something that's 20 feet tall suddenly spring into the air and fly away is outside the bounds of human experience.
For a giant like Quetzalcoatlus, flight control is everything. This flying reptile has one of the most advanced autopilot systems in natural history, akin to a bio-supercomputer.
Imagine just for a moment that you're an animal with the wingspan of a small sailplane. and you are turning yourself 90 degrees. That's not an easy maneuver to pull. Human pilots, for example, rely on instruments in their cockpit in order to do things like that. Quetzalcoatlus has to have those instruments built in.
A Quetzalcoatlus wing is covered with millions of tiny hair-like sensors. These microscopically small biomemory devices collect information, then send signals to the brain.
Their wing wasn't just an aerodynamic organ. It was also a gigantic sensory organ, capturing all kinds of aerodynamically relevant information about things like airspeed, tension in particular parts of the wing.
This data travels from the wing to the brain. Then, in a split second, a Quetzalcoatlus makes minute adjustments to its wing shape and body position. Proof of this advanced biotechnology is found in the flocculus, the area of the brain devoted to flight control. It's 3 times larger than in any bird today.
There's a huge amount of math going on in the brain as it's making these subconscious calculations. And what's key is that's happening all the time. It can never stop because these animals are in the air. And if there's any break in that process, the results are potentially catastrophic.
Nothing this large would achieve powered flight until the 20th century, 65 million years later. And Quetzalcoatlus still may hold the record for flight duration.
Probably stay aloft for a week. Probably could have gone for 26,000 miles in a single trip.
Quetzalcoatlus is one of the most unusual and terrifying carnivores to inhabit the Earth. But unlike predators such as T-Rex and Deinonychus, this flying meat-eater isn't searching for the big kill. It scours the Earth from above, tracking the small, the young, the defenseless, dinosaur hatchlings. Keeping this predator airborne at altitudes as high as 10,000 feet requires a 40-foot wingspan, an accurate guidance system, and near-perfect eyesight.
What we see is an enlarged eyeball, an enlarged eye socket, and the processing centers of the brain, the optic lobes, were also very much expanded.
Its 4-inch retina is packed with over 1 billion light receptors and registers as much as 4 times the detail of the human eye. A Quetzalcoatlus can also see a spectrum of light invisible to humans. Ultraviolet. The urine of their prey absorbs UV rays and then reflects them back. This creates a lighted trail leading straight to their quarry.
These animals had very highly developed gaze stabilization mechanisms, allowing to keep their target fixed and in focus within the crosshairs, if you will, as they were moving through space.
The secret to gaze stabilization is hidden in the inner ear. 3 interconnected tubes form what are called semicircular canals. Fluid fills each canal, and small hairs detect the tiniest movement. As a Quetzalcoatlus's head moves during flight, signals are sent directly to the eye muscles. The eyeballs adjust, keeping an image fixed and perfectly in focus. From 1,000 feet in the air, a Quetzalcoatlus can pick out a T-Rex nest and even count the number of chicks.
I think that a big pterosaur on the ground would have been spooky because they would be moving around on all 4s. They'd probably have those sort of quick, precise movements like birds, but they'd be huge.
Quetzalcoatlus lives by its own rules. Most meat-eaters keep their distance from the hatchlings of an apex predator, but not this reptile.
There probably weren't many animals in the Cretaceous that would dare to try to grab a baby Tyrannosaurus rex. A Quetzalcoatlus could probably manage it.
These big pterosaurs like Quetzalcoatlus were probably eating baby dinosaurs right and left. And then when they want to, boom, they push down, they spring into the air, and they flap away.
For Quetzalcoatlus, the key to snapping up baby dinosaurs is a quick getaway. But escape is no problem for a reptile that can pull 2.5 Gs on takeoff, reaching 30 miles per hour in less than a second.
If you're a Quetzalcoatlus and you live in a land full of tyrannosaurs in the latest Cretaceous, you need to take off in a hurry sometimes.
Quetzalcoatlus is unlike any other dinosaur in the Cretaceous. Speed, agility, and sophisticated biology allow it to survive for millions of years in a brutal environment. But this is a world inhabited by the most advanced predators nature has ever produced. Even prehistoric killers like Deinonychus and Tyrannosaurus rex know that no matter how many tools they have at the ready, attacking plant eaters is risky business. Every hunt might be your last. A mystique surrounds the mighty carnivores of the Cretaceous. They rule a dangerous world. But being a super predator like Tyrannosaurus rex is no easy job. Just surviving to adulthood is a major feat. One that takes a decade or more of killing and eating some of the meanest creatures that walk the earth.
The hardest role in the ecosystem is top predator. Most of the time, you are almost starving.
A carnivore knows that no prey animal goes down easily. Herbivores fight like their lives depend on it, because they do.
These are animals that have defenses.
Ankylosaurus is a slow lumbering plant eater. Its low-slung body is covered in bony plates, and its tail packs a punch.
Ankylosaurus itself has this huge mass of bone on the end of its tail. And there's no leg bone of Tyrannosaurus that can withstand it.
Predators of the Cretaceous are gigantic by our standard. Yet in stature, they're clearly outclassed by plant eaters. Carnivores, though, have one significant advantage: bigger brains.
The armored dinosaurs in general, and Ankylosaurus is no exception here, were not bright dinosaurs.
Probably one of the dumbest dinosaurs that ever lived. Their brains are really small for the size of their heads and their bodies.
With prey this dumb, predators don't need to be geniuses.
Ultimately, you really only need to be as smart or smarter than the animals that you're around.
7 tons of Tyrannosaurus rex can do a lot of damage, but a little extra brain can make a lot of difference.
Well, T-Rex brain was actually a bit larger than a banana.
T-Rex brain is just 1,000th of its body size. That's 20 times less brain power than humans. Yet, it's significantly larger than those of its plant-eater prey.
What we see in T-Rex is an advance. Its cognitive capabilities were greater. Its ability to probably solve problems and deal with wrinkles in its environment.
Other carnivores are even more dependent on cognitive thought. For protection, Deinonychus relies primarily on its brain.
The brain structure of Deinonychus and his relatives is really quite remarkable.
Pound for pound, Deinonychus has one of the largest brains in the dinosaur kingdom. That brain power is harnessed to achieve one goal.
This was an animal that needed some brain power to know how to attack, when to attack, what parts of the prey animal to attack.
The wily part of the brain is the cerebrum, and Deinonychus has a big one. It analyzes information from all over the body, and unlike the unsophisticated brains of its prey, it makes decisions. Deinonychus can also do something no other predator in its day could do: call in reinforcements.
What we can see with Deinonychus in its brain structure is that potentially it has the capacity to pull off cooperative hunting.
Deinonychus is clever. Clever enough to deal with another highly developed creature. A second Deinonychus. Hunting together requires an ability to communicate as well as share tactics and strategy. This is something only made possible by a large brain.
This is an animal that might have actually had some cleverness to it. An animal that might have actually been able to solve problems.
The ability to work cooperatively is the ability to stay alive. Deinonychus has to keep one step ahead of its prey, anticipating trouble before it happens. Living as a hunter was not the easy life.
The irony for many predators is they're very concerned about injuring themselves.
Even the toughest, most well-armed man-eaters regularly come face-to-face with prey that can kill them. Whether you have the jaws of Tyrannosaurus rex or are armed to the teeth like a raptor, every hunt just might be your last.
The thing about predation is it's very dangerous both for the prey and for the predator.
There are many specimens that have puncture wounds and open sores when they die.
An injury, even a minor one, can stop a predator from hunting. A virtual guarantee of death by starvation.
The life of a carnivore was so hard that they were beat up. They're all beat to hell before they became a fossil.
It's not like Africa or Asia today, where you have lots of smaller animals and there's one or two big things like elephants or rhinos. We're talking about an entire landscape that's filled with herds of multi-ton herbivores.
For carnivores today, just as during the Cretaceous, staying alive is tough, very tough.
If we look at lives of living predators today, they're pretty short lives. Each individual life does not span its potential. Whenever they become older and weaker, they're more susceptible to injury. And every time you hunt, you're putting your life on the line.
In the world of dinosaurs, predators stop at nothing to survive. They use every tool in their arsenal. Brains, eagle eyes, stealth flight, super hearing, and advanced sense of smell. But in the end, those who live by the claw sometimes die by the claw.